Hi everyone. We are going to discuss about abstraction in C++. Let's discuss what is abstraction. Now you know that when you're riding a car, there are a lot of complex features that goes behind, but you don't worry about them. Similarly, in C++ or any object-oriented programming, we have a feature that is known as abstraction. Using abstraction feature, we hide the complex details and we show only what is necessary for the user to see. Taking an example of a class, you might be having a lot of variables inside your class, but variables are not necessary for the user to see. User only sees some functions that are available for that user. So you only show those functions to the user, but you hide all the complex details behind it. Let's say we have a function which computes some algorithm and gives you a result. Now the algorithm can be very complex. A user doesn't want to know what are the complexity behind that algorithm. So the user only sees a function which uses that algorithm. This is what is known as abstraction. Now why do we need abstraction? Let's say in a car example, you might want to know what is going behind the engine, how the functionality of your car works. But is it necessary? No. Also, these details are very complex in nature. Hiding those details actually reduces the complexity, and since you're not worried about how the thing is done, so you improve on your efficiency also. These are the reasons we need abstraction. After knowing about what is abstraction, the second thing that comes in our mind is why is abstraction important, or why do we need abstraction? First thing is it simplifies our code. User doesn't need to understand what is going behind the scene. He only uses the interface to interact with your code. So in that way, it simplifies the world for the user. A user can focus on what he needs. In header files, we use math.h. Now math.h has some functions like power function. Power function can compute power in multiple ways. It can have multiple algorithms for computing the power, but we only use the power function. That is how abstraction becomes very important because we don't know what it is using. Most probably, the power function would be using the most efficient algorithm, but we are not bothered about it. We don't know how it is done, and we also don't need to know it. We just know, okay, we have a power function, we can apply these values to it, and we'll get the result. So this is how abstraction works. Also, when we are doing abstraction, encapsulation also comes into the picture. Why? Because when you're showing only certain details to the user, you are having some interface or function, you actually combine your functions with your variables, and you hide the variables and show only the function. You don't want to show what variables are you using or what complex algorithm you are using. So now you combine your variables with your functions that are working on those variables, so they become very closely bound. And that is another feature of C++ that is called encapsulation. I told you about a car. When you're driving a car, you don't need to understand how the engine is working, how your brakes, gears, or whatever is working. You only know how to use them. So the focus shifts from how to use. For a user, usage is the most important thing, and we focus on that through abstraction. In C++, we have two types of abstraction. One is control abstraction, where you hide the process how you're doing it. And second is data abstraction, where you abstract your data or information in a class, all the data members, you try to hide them. Now, when you're talking about abstraction in terms of control, when you're hiding your functionality, how you're doing it, what algorithms you are using, how things are being done, that is control abstraction. And data abstraction is whatever data you have in the class, you try to hide that. You don't want user to know what all variables you have, how you're using them, how you're functioning on them. So these details are not actually needed by the user, and also these are very important for internal use, not for the user. You don't want to show user how things are done. Going into detail about data abstraction. How do we achieve data abstraction? We have two ways of achieving data abstraction. One is using classes, where you hide all the data members and some member functions from the user. How do you do it? You combine your data members with your member functions. You have some public member functions which are available for the user. When you're using classes, you have some private members which are hidden from the user. Then you have some public members which are available for the user. So you only have those variables or those functions as public which you want to show to the user. So in that way, classes combine these two things and hides some of its member using your access specifier and only show the ones you want to show to the user. Now the second way to achieve abstraction in C++, we always have some header files when we are creating any program, and all these header files have functions in it. For example, your power function or your absolute function or whatever type of functions you use through your header files. These are all the example of abstraction. I told you that we achieve abstraction through access specifier, but what are these access specifiers? In C++ or in many languages, we have three types of access specifiers. One is your private, which specifies all of your private members. Now what happens is, when you define anything as private, that thing is not available for the user. Also, when you are inheriting any class, then the private members are not visible to your subclass. Second type of access specifier is your public specifier. Now whatever you declare as public is available to your user and your subclass as well. Now when you say anything public, that is where you have all these things which you want to show to your user. Like I say power function. Now the power function is actually a public member, so it is available for every user. In the same way, when you say anything is private, that is private to that class, that is not available to anyone beyond that class. We also have a third type of specifier that is called protected specifier. What happens with protected members is, when you say anything is a protected member, that variable or that function becomes part of your subclass as well. Whenever you are inheriting any class, your protected members are also inherited. And also when any of the friend class of your class which has the protected member try to access protected members, for that class also protected members are available. Generally we don't use protected specifier in most cases, but if you have any case wherein your friend class or your derived class need to have the access of that member, but anyone apart from that doesn't need to have that access, then you can put them in your protected section. This is an example of your abstraction. Here you can see I have two variables, those are private. So what happens in this case is, your x and y variable is not available to anyone beyond this class scope. If you have any of your child class or your friend class or anyone using this class, your x and y is not available for them. When I say I have some public function, so your set function will be available for users. What does that mean? That you say that I have a class test abstraction which have two functions. One is set, wherein you can give two variables. The user is not informed what happens inside this. And then you say I have another function, that is print function, that will print x and y. The user has the access to the set function and the print function, and whenever he calls set function with two variables, the compiler sets the variable of x and y with those variables, and whenever user calls print function, the compiler shows x value and the y value. One more very important topic when we are talking about abstraction is abstract classes. Abstract classes are those classes for which you cannot create any object. So these are just like a skeleton. Why do we need this? We provide a skeleton for a concrete class. Let's say I have a class animal. Now generally we don't create object of animal, but what we have is, we have a cat, we have a dog, and we have other types of animals. So we can say that animal is an abstract class, and a concrete class to that which inherits your animal class and have some extra features, then creates a object. Like dog class. Dog class inherits your animal class. It has some of its own features, and then you can have an object of dog class. But since your animal class was an abstract class, you cannot create objects of animal class. In a way, we just provide a skeleton, and when you're talking about skeleton, you cannot create objects of your skeleton. It just provides a blueprint for what are some features that are common in all those classes which inherits this class. Also, abstract class becomes very important when we are talking about interfaces. Let's say I have an interface. I say these are the functions. I provide these interfaces to the user. Now, how these are implemented? These are implemented in your child class. Let's say I have an abstract class shape which has a function draw. I can have multiple subclasses, let's say circle, rectangle, or square, but all these will have your draw function. Now I can provide the user interface that you can use draw function for all these classes. You have this interface and user just uses that interface. Okay, it calls the interface draw function, and whatever object value it has provided for a class, that class implementation is actually called. So in this way you can optimize your code, you can manage your code very easily with this. Let's say you have some functions which are common to all these classes. You just need to have one call to the function and you can provide whatever object you had. It will print that object's function. So this way you can simplify your code to very large extent. This is an example of your abstract class. Herein you have your function draw, which is a pure virtual function. Whenever we have any pure virtual function in a class, we cannot create object of this class. Then we have an implementation of this class name as circle. First thing that we need to do is we have to provide the implementation of this draw function. So here we provide this implementation. If we had square class also, which inherits shape class, we will need to have this implementation of draw function in that class also. And this way we can create pointer to this shape class, and we can provide the value of circle or square to that, and in that way we can call draw function, and whatever value it has, whether it be of circle or of your square, on those basis that pointer will call this implementation or that implementation. After we have discussed about what is abstraction, how we use it, what are abstract classes, now this one more question that comes in our mind is, what are the advantages of abstraction? In a nutshell, we have three advantages of abstraction. One is your code reusability. When you are using abstract classes, you reuse the code wherever you can reuse. Then the second thing is easier maintenance. When you divide your code into multiple classes, when you hide something from the other classes, this becomes disjoint things. And when you have disjoint things, these are very easy to manage. So if you just show two functions to the outer world, to the user, you just need to show those two only, and whatever you change inside it, let's say you change the algorithm. Let's say I had a function of power in my class, I had some implementation, I had some algorithm for that function. Now I want to change the algorithm for that function. I think that algorithm was not very efficient, I want to change it. I can easily change it because it is not going to impact anyone outside my class. So in that way these become very easy to maintain. Now one more thing is flexibility. Let's say I have a class. I had two functions which were visible to the outer world, which were public. Now I want to add one more function in my class. I can easily do that. Nobody is getting impacted. So in that way, it becomes very flexible to add on things in your class or change anything inside your class. Your outer things are not affected. Now, when we are talking about abstraction, many people confuse abstraction with encapsulation. When we are talking about abstraction, the main focus is on hiding the complexity inside your class. We achieve that through encapsulation, but the purpose of abstraction is to hide the implementation. Whereas for encapsulation, the main thing is it tries to restrict the access to the components of your class. We restrict the access of the user in our classes. The purpose of abstraction and encapsulation are different, but they always go hand in hand. That's it for abstraction. If you have anything, you can drop a comment. Thank you.